Hello everyone, welcome in a new video. In this video, we are going to start a new chapter which is a process synchronization. Okay, now we understand that how is basically process communicating with each other, how the process is basically synchronized so that they can use a single resources. Okay, so we discuss about the synchronization. Okay, so first of all, to understand the process synchronization, we need to understand that meaning of a synchronization. So synchronization meaning in a very simple way, it means that process are communicating at the same time. Process are communicating at a same time. At a same time. Okay. Means whatever the processes we have, these processes are communicating at a same time. Means if let's say we have a process, let's say P1 and P2, and both process want to use a resource, let's say X. Okay, so P1 also want this resource, P2 also want to use this resource. Okay, so both the process are communicating at a same when the both the process are communicating at the same time to get a value of this particular shared variable, then we can say that these processes are synchronized. Okay, when both the processes are interacting with the resource at the same time, this is the meaning of a synchronization or a process synchronization. Okay, so to understand the process synchronization in detail, the one thing that we need to know is a system call. Is a system call. So if you watch a video of a mode bit my mode bit video, then you understand a system call very much. But now we need to understand system call a little bit more detailed, because in a process synchronization, when the process are using a shared resources, how they basically use the shared resources, how they communicating, how the switching taking place, because in our system there is only one CPU, so one process can execute at a time. Okay, it means what? It means the context switching between the processes is taking place. So how these things work, how this thing works, so we need to understand this. Okay, so for that, first of all, we need to understand about a system call. So system call is basically a programmatic way in which the computer program request to perform some services. Okay, so what is a system call? System call is basically a programmatic way in which computer program request a service from kernel, or you can say an operating system. This is what a system call is. Okay, we simply discuss a system call in a brief, because we discuss a lot of thing about a system call in that previous videos. So if you want to know detailed thing about a system call, then you need to watch the mode video. Okay, the link is in a description. So this is what a system call is: a programmatic way in which the computer program requests to perform some services, okay, from kernel. Okay, so what basically happen in a system call? In a system call, the process basically executed like, first of all, request is going to the from a user space to a kernel space. So request of a process request of a process is first of all going on process from user space, or you can say a user okay, means first of all, whatever you want to perform, let's say you want to save the file, so what you do, you write control S. It means what? You call a system. This is what a system call is: when you request from a kernel, when you request from an operating system to perform some task. Control S is what? To save the thing. If you are doing something on a word, and when you complete your task, so what you do, you save that file. So what you click? You click control S. You click on control S. So the control S is basically what? A system call. Control S is what? Control S is a system call. So request is basically a request of a process is given from a user space to a kernel space. Then what happen? request is moved from a user to kernel, it means kernel have to interrupt. Okay, so the interrupt request from kernel is happen. Interrupt request for kernel, and these two things are basically called as a trap OS as well. Trap to OS. This is also called trap to OS. After that, after the interrupt, what happened after the interrupt, when kernel know about, okay, so this is what a request is coming from a user space. Now what happened is the kernel mode is now on. Now we are in a user mode, that's why user can able to send a request. When you click Control S for saving the file, when you click on a Control S, now the kernel mode is start. Now kernel mode is active. Okay, so what happened? Control is transferred from a kernel user mode to kernel mode. So control is transfer. Control is transfer. This is what called kernel mode. This is what we call kernel mode. After that, what happened? Kernel check that if the operation can be done or not. So kernel check if operation can be done or not. After that, what happened? After that, if kernel can able to do that task, so what kernel do? Kernel perform that task. Okay, so kernel perform that operation. Kernel perform operation. Kernel perform that operation. Now what happened when kernel perform that operation? If kernel does the task, kernel save the file, what happened then? Kernel return that what basically they do. Kernel return the output. What happened? Kernel return the output. Kernel return the output to the user. Okay, so this is what happened in a system call. How the system call is basically work. Okay, so now we understand a system call, a bit about the system call. Now we are moving towards a very important topic, which is a fork system call. Fork system call. Okay, so this is very important. If you are preparing for a gate, then this question appear on a fork is a very frequent. Okay, so what is a fork system call? Fork system call is used for creating a new processes. Fork system call, it is used for creating, new processes. It is used for creating new processes. Okay, it is used for creating new processes, or you can say a child processes, new processes or child processes. Okay, new processes or child process used for creating a new processes, which is called a child processes as well. Okay, and what is basically fork is what basically a child process is. So child process is basically similar to like a process, similar to like a we have a, let's say, process, let's say P1. Okay, so what this is called, P1 is called a parent process. P1 is called a parent process. Okay, similar, the now what we are going to do is if we write fork, then what basically happen is P11, let's say P11 created similar to like P1 process. Okay, but the both are the processes. The important thing is both are the processes. In threading, what we are basically have, we have one process and so many threads of that particular process. But in fork, what happened is we have basically created a new process. We have now two processes. One is called a parent process and another is called a child process. One is called a parent process and the process which newly created process is called a child process. Okay, both of the processes are basically perform a different thing. Parent process, whole program is called a parent process. Child process means wherever you use fork, after that whatever the thing is, whatever the task is, that process, the completion of that task is basically the child process. Okay, let's understand this thing in detail with an example. Okay, so let's say we have a C program, void main, a main function. Okay, we have a main function. Now what happen is in this main function we write print hello. Okay, so what happen if I write like this? So what will be the output? So output is very simple, output is hello. Now what I do is I simply do the system call, which is fork. Now after that we are going to print by. So this is what our complete this is what our complete program is. Okay, so now what happened? What will be the output? Is hello by written, or just hello written, or just by written? What will be the output? So the output is hello by, hello by, and by. How is this possible? What basically these things happen? What happen here when by is printing two times, whereas hello is printing only one time? What basically happen here? So let's understand this thing. So first of all, program is executing from a main function. So main function is executed. After that, what basically the print is? Print hello. Okay, so it print hello. Now hello is printed. Hello is printed. After that, it moved towards the next cursor, which is a fork. Now what happen is when hello is printed, it call fork. Now fork divide a process into two parts. Fork divide a process into two parts. What we discuss here. One is called a parent process. One is called a parent process, and other is called a child process. Both are the processes. These are not thread. The new process is not a thread, it's also a process. Okay, so whatever basically have p, the parent process, same thing is having with a child process. Okay, so now what happened after that? After that, parent process execute and child process execute. Both the processes are executing. So now moving towards the parent process. After fork, what happen is by is printed. So parent process print by. Now moving towards the child process. After fork, what basically we have a print by. So child process is also print by. Child process is also print by. So the overall output is like hello, then parent process and the child process. So answer is like hello, by, and by. Hello, by, and by. So I hope you understand this thing, that how the fork is basically work. Whenever we call fork, it divide into two parts, parent process and a child process. Both of these processes are executing the same thing. Both of these processes are executing the same thing. If I write here the print f, okay, so parent process is also printed okay, and child process is also print okay. Both the processes are printed okay. So the output will be like hello, by, okay, by, okay. Okay, so what fork does? Fork created into a fork distributed a process into a two process, parent process and a child process. Okay, so there is any difference, there is anything which basically, because we are doing the same thing, the parent process is also doing the same thing what the child process does. So what is basically a difference in a program point of view? So let's see this thing. Okay, and one more thing is that child process run concurrently with our main process, with our parent process. Means both the process are running concurrently. Parent, I write here as well, like parent process and child process are run or execute concurrently with the process. Okay, so I write concurrently with the process that make fork, or if I write like this, then we simply remove like parent. Child process are executing concurrently with the process that create fork, means a parent process, okay? So both the processes are executing concurrently. Now what is the meaning of a concurrently? Okay, so concurrently, there is a difference between a parallel and concurrently. Parallelly and a concurrently. The parallelly means we have more than one CPU. Let's say CPU number 1 and CPU number 2. CPU number 1 executing the process, CPU number 2 executing a process, let's say the process P1, P2. So both processes are executing at the same time, then we can say that both the processes are executing parallelly. when both the processes are executing at the same time. Okay, but concurrently means we have one CPU in a system, we have one CPU. Okay, we have one CPU, but we have more than one process. So let's say P1, let's say we have a two process P1 and P2. So what happens is, how concurrently means is, P1 is executing for some amount of a time, then P2 is executing for some amount of a time, then P3 executing some amount of a time, then let's say P1 again executing, then P2. So whatever process basically come, they executing in a round robin manner. They executing in a round robin manner, but there is a catch is in concurrently means, in a concurrently basic there is no time quantum, but everything is similar like RR, but no time quantum. Everything is similar to like RR, round robin, but there is no time quantum. Okay, so this is the meaning of a concurrently. Okay, so child process execute in a concurrent manner. Child process execute in a concurrent manner. And there is one more thing as well, so which I told you that what is the difference, because parent process also printing the same thing, child process is also printing the same thing. So what is the difference? So the difference is child process returns something. Child process returns something. It returns some values. It returns some values, and that value is very useful in a parent process, because in a parent process, let's say there is some conditions, that condition can be proved by the child process. So let's understand this thing. What basically I want to say, that the child process is returning something. So okay, so let's say that first of all, what basically the child process returning, so it can return a negative integer. It can return a negative integer. Okay, when you create a child process, it returns something. If it is able to, when let's say fork is called and parent and child two process are created. Okay, parent and child, let's say under some circumstances, there some condition is like that the child process are not able to create. Creation does not take place, means the creation is not happen, the creation of a child process is not happen. In that case, the parent process receives some negative value. Parent process received a negative value. So negative integer, when it receive a negative integer, or you can say the negative value, when the parent process receive this negative value, when the creation of a child process, when the creation of a child process is unsuccessful. When the creation of a child process is unsuccessful. Okay, so I hope you understand about the negative values. Now it can receive 0 as well. It can receive 0 as well. When this is what, when it basically receives 0, it returns 0. It returns 0 towards the child process. Parent process receive a negative value, so child process is basically is also a process, so it also receives something. It receives 0 when the successful creation of a child process is happen. So child process get 0 when, or you can say, you can write it like this: child 0 is returned to the newly created child process. Newly created child process is basically get a 0. Parent get a negative value, child get a positive value, child get a 0. Okay, child get a 0. Now who received the positive value? So the positive value is received by the parent. Negative value and the positive value, both the value are received by the parent. Positive value is received when the successful creation of a child process is happen. If a child process is created, then 0 is assigned towards the child process and a positive value is assigned towards a parent process. Okay, so returned to parent, or you can say a caller. Return to parent, or you can say a caller. Okay, so like this, when fork is called, when the distribution of a process is happen, when a process is created, let's say parent process and a child process, parent process received a positive value, let's say 1, when there is a successful creation, when there is a successful creation of a child process. If successful child process successfully created, then parent received what? A positive value, let's say 1, and child process received a 0. Child process received a 0. But if a child process is not created, the creation of a child process was unsuccessful, then this will receive a negative value, let's say minus. Okay. So this is what a difference between a child process and a parent process in a broader way. Okay. These values are very important when you are solving the question. So these values are very important. Let's solve one question related to these things and we are done with this video. Okay. So we have a program, we have a C program like void main. Okay. This is what a main program is, and a condition is like fork and print hello. So this thing happen. This is what our program is look like. Okay, void main fork print hello. Now what will be the output? What will be the output? Is hello is printed only once? Is hello is printed on twice? Is hello is printed thrice? So what will be the output? Okay, come and pause the video and try to solve it by yourself. Distribute this fork in a two processes, parent and a child, and execute both process. Okay, so let's do this. So fork, because first of all cursor is like here. After that cursor is goes towards the condition. In condition what basically happen is fork. Now this fork returns something for some process. For a parent process it can return a negative value or a positive value, and for a child it returns 0 if the creation of a child is successful. So let's say the creation of a child is successful. Okay, so the two processes now created, parent process and a child process. Two processes created, parent process and a child process. Now if a successful creation of a process is there, the successful creation of a child process is there, then the child process received 0 and parent process received a positive integer. Okay, parent process received a positive integer and a child process received a 0. Now both the processes are executing concurrently. So first of all, let's say for the parent process, what will be the condition? Condition is like here, right? Like condition is like a non-integer here, a positive value here. So if in a condition there is a positive value, what basically this means? This means you can go inside the braces. It means the condition is true. Now you can execute whatever written in this particular block. Okay, so what is written in the particular block? Hello. So print hello is successfully printed, and first of all the output is what basically happened the output of a parent process is the first output. So hello is printed now. Hello is printed. Now moving towards the child process, it returns 0. So what happen if condition like if 0? Now what happen? It means what? There is no positive value. It means what? It means condition is false. So whatever written inside this is not executed. Whatever is written inside this block is not executed. It means the child process doesn't print anything and a parent process print hello. So the output is only hello. So I hope you understand this thing, that how is basically fork work. Okay, the how fork system call is basically work. Child process is basically having a 0 on a successful creation, and a parent process receive a positive value. Okay, so this is what our output. Okay, so this is all about in this video. Thank you for watching this video. Click on the next video to understand fork in detail. Okay, we solve some more questions on a fork. You will be crystal clear when you see that video. Okay, so click on the next video. Thank you for watching this.